Hard Electric Motor Division, General Motors Corporation, Maintenance Instruction 1601, Dynamic Brake Grid Resistors. Introduction. A properly maintained dynamic brake grid system will provide a grid life equal to the lifetime of the motive power equipment associated to equipment that directly affect the grid resistor. Therefore, proper function of the cooling fan, regulators, and cabling is essential. Description: locomotive with dynamic grid is a 700 ampere resistor for the off-highway vehicle. Grid is rated at 10,075 amp. 1,075 amps. Each grid is encased with a sturdy frame compromised with a tandem half box construction. Figure 1, a front air in, rear air out ribbon assembly converts electrical energy into heat. The ribbon is assembled with the existing preset thermal expansion gap, and it's held firmly in place by clip of the ribbon side half of the wider space. Figure 1 allows insertion of the additional ribbon and convolutions required to ensure the optimum resistance. Polyester baffled along each side with ensures proper airflow. Since the grid is built by assembling two basic half boxes, partially failed grids can be easily and economically repaired by replacing defective half box. Dynamic braking resistors with the associated cooling fan and the motor usually grouped in this subassembly, which trim mounted in the superstructure of the locomotive. Typical SD2 for grid fan configuration involves 6 grids and 2 fans. Figure 2, typically the GP2 configuration consists of 4 grids, 1 fan. Figure 3. Alright, dynamic braking resistor with motor tap. Shows the clips at 12, baffle, rear half box, front half box, ribbon assembly, motor tap, and clips. Alright, so we have a motor push button, traction motor 1, switch number 14, traction motor 4, MB switch, push button, resistor, braking motor, grid 142, grid B3, grid 162, grid C3, 3, 2, 1, grid D 1 to 2, MB push button, traction motor 2, switch number 25, traction motor number 5, MB, grid 3, 2 to 1. So grid C, A, B, and E in the middle are all 1 to 2. Grid C, A, and E are 3 on the right. Grid B, grid D, and grid F are 3. Grid F has a 1 to 4 to 2 with a resistor to the braking motor. Main breaker, traction motor, switch 36, traction motor 6, main brake. So locomotives equipped with the basic dynamic braking grid. This is a traction motor 1, 2, 3 on the left, traction motor 4, 5, and 6. Alright, locomotive equipped with extended range dynamic brakes, typical SD2 configuration, MB button switch, traction motor switch 14, traction motor 1, 2, 3 on the left, traction motors, 2 resistors or induction coils, 2 braking motors, grid 142, 142, grid B and F, traction motor 2, grid 3, motor button. So in the center you have grid B, D, and A, and C at 3, grid B 1, 4, 1, 2, 1, 2, 1, 2 on the top, and then on the bottom you have grid F 1, 4, 2, grid F 3, grid E 3, 2, grid E 3 to 3, 3 to 2. That's 6 traction motors, switches 14 and 36, 25. Push button, direct current 1, 2, and 3, knife switch. Alright, locomotives equipped with the basic dynamic brakes, traction motor 1, 2, 3, and 4, main button MB, power contactor 3 and 4, main breaker is on the outside. There's 4 of them on each traction motor equipped, and then in the end 2 on the first 1 to 2. Grid B 142, grid B 3, grid C 3 to 2, grid C 1, and that goes back to grid A 3, grid A1 to 2, grid D1, grid D3 to 2, induction coil BM. Alright, typical GP2 configuration. Traction motor 1, MB, M2, power 3, traction motor 3, MB, grid B142, inductor BM, grid B3, MB2, M3, MB, P34, resistor OCP, BR2, push button, DC 1, 2 and 3, knife switch, grid D, 1 to 2, grid A, 2 to 1, grid C, 2 to 1, grid 3D, grid A, grid 3C. Alright, electrical schematics figure 2 and 3 cover the both basic and extended range dynamic braking system. Typical OH off-highway vehicle grid fan arrangement shown in figure 4. Grids are located on vehicle upper deck. Operation. Dynamic braking is a system used to retard speed through conversion of kinetic energy to electrical energy. During dynamic braking, power to developed by the traction motors acting as separately excited generators dissipated through the dynamic braking grids into the form of heat. The amount of kinetic energy converted with electrical energy proportional to amperes squared times resistance, where amperes brake grid recurrent resistance is the effect of the resistance of the braking grid. Grid current increase with the maximum value at the speed of the maximum braking effort is attained and regulated to the maximum value at all higher speeds. Typical OHV configuration has motor 1, motor 2, CDR, power contactors, and it has 4 different resistors grid with a BKC, 2 rectifying zeros, a shunt. Rating factors. There are many types of dynamic braking hatches. Some leave ventilation, usually suction, provided with the most uniform cooling. However, the main factors influence effectiveness of the cooling air. 1. Distance fan from the grids, angle with which grids are set with the present protective gratings, fan motor size, location, motor type, motor tap on motor tap grid. Ampere rating grid specified for the hatch for location established to provide adequate safety margin, wind direction, ambient temperature variations which occur within the other areas directly affected with the grid cooling power. Grid rating is established gradually increase with the current loading in the dark. The current in amperes at which first grid configuration starts to show the very dull red haze is noted. Maximum operating current from this resistor configuration establishes 10% less than the current excited at the cooler threshold. Resistor types. In every given configuration of resistors, there's at least one resistor with special tap for the blower motor. Figure 1, the resistor has the so your BM was actually a blower motor. Resistance valve, I forgot. The resistor with a different resistance value of the companion resistors as well, with having extra tap. The motor of the tap position provided with the desired fan speed with grid, given the value with the current with the total value with the grid resistance, such as the total power consumed with the motor tap grid and cooling fan motor is the same as the consumed by the one untapped grids in the same configuration with the given the current flows from them. Certain resistors are provided with the center tap, figure 5, so the taps are used for the control purposes or for series parallel arrangement when loading the engine. So here's the control tap, number 1 and number 2 and number 3, dynamic braking grid resistor, ventilation. All resistors require a large amount of ventilation air with the operated rated current value with the proper amount of air furnished with the dynamic braking grid. Blower fan is tapped across the section of one of the resistors. Note practically integral relation exists between the grid blower fan and the grid resistor. Proper maintenance of the cooling fan motor components include bearing brushes, cabling, alignment for procedures is stressed. Further maintenance instruction 4104. Insulation and operation of the entire resistor is above the ground electrically as a component with a new and the rebuilt unit with the resistor expected to withstand 3200 voltage AC at 60 Hz high potential test for 1 minute during the operation of resistors, usually electrically isolated with a disconnect with the ground connection with the power circuit. A potential of 500-600 volts exists between the terminals with the resistors. It's a common practice to put 2 resistors in series with the armature outputs for the 2 traction generators. Therefore, 1200 volts the ground may exist during the operation, insulating damage of the portion of the resistor may short out either directly or by with a double ground. terminals. Since the current carrying capacity for the grid is measured for the hundreds of amperes, the cable of the current carrying current to the grid is of necessity bulky and stiff. The grid terminals are regularly constructed to withstand severe pulling and twisting at cable lugs. Note the contact strip of the cable lug and terminals must be kept free from the corrosion. Disassembly. Many variations of the disassembly and assembly procedure exist among various grids, determining the applicability to perform one of the following procedures. Refer to service data to determine the proper procedure. Procedure number 1, figure 6. Don't retain all parts removed during the disassembly for possible reuse. 1. Prior to disassembly, necessary to remove the 6-volt lock washer with it attached to the grid structure. So we'll back out of this. One is the front half box, which is the top. 2 rear half box. 3 side plate. 4 slide panel. Slide plate. 5 terminal support. 6 support bracket. 7 3x8 16 by 1.5 inch hex mounting screws. 7 8 9 polyester air baffle. Alright, 2. Remove the number 2 1/4 by 21 and 3/4 inch hex screws, self-locking nuts on each side of the plate. 3. And remove the 2 support. 5 and the support bracket. 6. Remove 3/8 inch 16 with a 1 1/4 inch hex screw from the number 2 terminal. Remove the 3/8 inch 6 by 16 by 1 1/4 inch hex mounting screws. 7 of them at each end of the assembly. 6. Partially separate the front and rear half of the boxes. Remove the 2 polyester air baffles. 8 and 9 with a retained between the front and rear half boxes. 7. Slide the rear half box 2 with the straight back into the terminal stamp. 3 and 2. Clear the front half box 1 frame. Procedure number 2, figure 7. Note, retain all parts. Remove the disassembly with a possible reuse. Prior to the disassembly necessary, remove the 6-bolt lock washer with attached to the grid structure. To remove the terminal support. 3 and 4 support bracket. 4. 3. Remove 3/8 inch 16 by 1 1/4 inch hex screws from the number 2 terminal. So you have 1 and 2 halves. Slot support. Item 3 must engage insulator. Sketch 3. Use 2 flat parts. Marks X. Right here, number 1 and number 2 and number 3, sketch B, controlled trap. Terminal number 1, number 2 and number 3, 6 and 7 polyester air baffles. 4. Remove 1/2 inch 13 by 1 1/4 inch hex screws. 5 at each end of the assembly. 5. Partially separate the front and rear half of the boxes. Remove the 2 polyester air baffles. 6 and 7 of them retained between the front and rear half boxes. 6. Slide rear half box 2 straight back until the terminal stamp. 3 and 2. Clear from the front of the half box 1 frame. Procedure number 3. Figure 8. Note, retain all parts. Remove the disassembly with a possible reuse. Remove the terminal support 3 and support bracket 4. Remove the 3/8 inch 16 by 1 inch with a 1 1/2 inch 13 by 1 1/4 inch hex screws for the number 4 terminal. Remove 4 1 1/2 inch 13 by 1 1/4 inch hex nut screws. Hex mounting screws from each end of the assembly. 4. Partially separate with the front and rear half of the box. Remove the 2 polyester air baffles. 6 and 7 retained between the front and rear half box. Slide with the rear half box 2 straight back until the terminal stamp. 3 and 4 clear with the front half box 1 frame. Inspection. Visually inspect the grid. Remove all foreign material which is lodged with the resistors. This can be accomplished with blowing compressed air through the ribbons. Inspect the half box assembling with a wrap the burned ribbon by looking through the ribbon assembly. If the warped or burned ribbon is found, replace the half box assembly with the proper replacement part numbers. Refer to service data for further data. Assembly procedure number 1. Place rear half box box 2 figure 6 directly behind the front box 1 with the number 3 with the number 1 terminal at the same side, and 2. Slide the front rear half box 1 and 2 together with a single number 2 terminal with the front half box 1 positioned between the double number 2 terminal with the rear half box 2. 3. Reinstall 2 polyester air baffles and 8 and 9 between front and rear half boxes. Figure 9. 4. Reinstall 4 3/8 inch 16 by 1 1/4 inch hex tandem mounting screws. 7. Figure 6. 3/8 inch lock washer nuts at each end of the resistor with the 2 3/8 inch flat washers on each side of the frame flange. Line front and rear frame of the top sides within 1/16 of an inch before the tightening of the bolts raised to the front half of the box, 1/4 inch with aid alignment. Note: reuse original terminal support parts except when they are supplied with a new front half box. Reinstall with 5. Reinstall the terminal support bracket 6 using 3/8 inch 16 by 1 inch. Head screws, lock washer, and nuts do not tighten. 6. Reinstall polyester terminal support bar 6 using 3/8 inch 16 by 1.5 inch. Hex screws through the support bracket 3/8 inch by 1 1/3. The screws through the 2 terminals installed as shown as the 2 flat washers against the support bar points at marked X. Add 3/8 inch lock washer and nut. Note: ensure the slot support bar 6 engages 660 60,000 of an inch thick barrier extending from the front half box, medium of 20 hundredths of an inch, figure 10. Tighten all terminal supports and bracket mounting bolts. Reinstall 3/8 inch 16 by 1/4 inch hex screw through the small diameter hole number 2 for the terminal sandwich. Assembly using 3/8 inch flat washers, lock washers, and nuts. Ensure 1/2 inch diameter rod bolt will pass through with the large diameter hole before tightening. 9. Mount 2 side plates, figure 3 and 4, and figure 6 using 1/2 inch 20 by 1 3/4 inch hex screws. L-shaped clamp and lock 9 center side plates. Do not over tighten. 10. Recheck all mounting hardware and part alignment. 11. High pot completely assembled. See high pot test section. Procedure 2, figure 7. Place rear half box 2 directly behind the half box 1 with the number 3 and the number 1 terminal at the same end in sight. Slide the front and rear half boxes 1 and 2 together with a single number 2 terminal with the front box 1 position between them, the double number 2 terminal with the rear half box 2. 3. Reinstall 2 polyester air baffles 6 and 7 between the front and rear half box of the frame position baffle to engage notches and terminals. 4. Reinstall the 1/2 inch 13 by 1 1/4 inch hex tandem mounting screws. 5 of the 1/4 inch lock washers nuts each end of the position. Use flat washers on each side of the frame flange. Note: reuse original terminal supports except those which, when they are supplied with a new front half box. Reinstall the terminal support bracket 4 using 2 3/8 inch 16 by 1 inch hex screws, lock washers, nuts do not tighten. Reinstall polyester terminal support bar using bar 4 3/8 inch 16 by 1.5 inch hex screws through the support bracket 3/8 inch 16 by 1 3/4 inch hex screw for the 2 terminals installed with the shown E for the 2 flat washers again to the support bar at marked X. Add 3/8 inch lock washer and nuts. Ensure slot and support bar 4 engages 60 thousandths of an inch thick barrier extending with the front half box, a minimum of 20 hundredths of an inch. Figure 7. The tightening terminal support with the bracking mounting bolts. Reinstall 3/8 inch 16 by 1 1/4 inch hex screws through the small diameter holes in the number 2 terminal sandwich. Assembly 3/8 inch flat washer, lock washer, nut. Ensure 1/2 inch diameter rod bolt will pass through with the large diameter hole between before tightening. 9. Recheck all mounting hardware part alignment. 10. High pot completed assembly high pot test section. Procedure number 3, figure 8. Place rear half box 2 directly behind the half box 1 with the number 3 and the number 1 terminal with the same end. 2. Slide with the front rear half box to go to the single with the number 4 terminal with the front half box position between the double number 4 terminal on the rear half box. Reinstall 2 polyester air baffles and 6 and 7 between the front and rear half box frame position baffles to engage notches and terminals. 4. Reinstall 1/2 inch 13 by 1 1/4 inch hex and tandem mounting screws. 5. 1/2 inch lock washer nuts at each end of the positioner using flat washer on each side of the frame flange. Note: reuse original terminal support parts except when they are supplied with a new front half box. 5. Reinstall the terminal support bracket 4 using 2 3/8 inch 16 by 1 inch hex screws, lock washers, nuts do not tighten. Reinstall the polyester terminal support bar. 3. Using 3/8 inch 16 by 1 1/2 inch hex screws through the support bracket 3/8 inch and the 16 by 1 3/4 inch hex screws for the 2 terminals installed and shown on the 2 flat washers against support bars at points marked X. Add 3/8 inch lock washer and nuts. Note: ensure slot support bar 3 engages 60 thousandths of an inch thick barrier extending with the front half box, minimum of 20 thousandths or 20 hundredths of an inch. Figure 8. Tighten with all terminal supports and bracket mounting Bolts, reinstall 3/8 inch 16 by 1 inch hack screw through the small diameter holes. Number 4, terminal sandwich, assembly 3/8 inch flat washer, lock washer, and nut. Reinstall with a 1/2 inch 13 by 1 1/4 inch hack screw through the remaining large diameter holes using the flat washer, lock washer, and nut. Check all mounting hardware and part alignment. 10, high pot. Completed assembly. See high pot testing section. High pot test procedure. Preferable time to perform high potential tests is soon after the locomotive has completed with the run. In such instances, if the equipment is warm and dry, with eliminating possibility of the moisture being present, units that have been shut down for the extended period of time prior to making high potential test circuit insulation resistance should be checked with a suitable megometer. Readings of less than 1 megohm should be viewed as suspicious. High potential tests in such instances may cause a breakdown of the insulation to produce the risk of possibility caused low megometer readings should be determined incorrect. If this may be done by reducing the complete circuit concerned with the individual circuits which are isolated and checked separately. In this way, the circuit portion of the equipment causing the low reading of it can be found. Correction may often be made through the cleaning and the drying of the affected areas. Troubleshooting, indicating previously improper maintenance of the malfunction fan motor related to equipment and major cause of the dynamic braking grid failure. Therefore, following checklist is offered with a handy inspection guide to ensure with against practice the conditions which may contribute to a result of the dynamic brake fan grid failure. Fan or grid failure. Inspection reveals the existence of the adverse condition. Proper repair maintenance procedures should be initiated. Note the recommended procedure repairing partially failed grids is a half-box replacement. Refer to service data of the replacement parts available through the electromotive parts center. Refer to parts catalog. Checklist fan motor overly tight in rotation, bearing noise, greasy leaks, flash damage, brush short, shunts frayed or burned, brush holder studs loose, check condition, stator insulation, lead shaft and shorted, lead support loose, check condition of armature wire bands, fan rubbing inside diameter of frame, blades cracked. 12, check condition of fan motor enclosure, grids, ribbons out of clips, terminal support bolts loose, lack of ventilation, polyester baffles in place, terminal support insulator broken, impact damage ribbons or terminals. 7, ribbons misaligned due to warp, hot spots, or welds. Note, ribbon alignment is easily determined holding the light behind the grid assembly. Visually checking improper hoisting practice causes frame malformation. 9, foreign material present, nuts, bolts, tapes, and paper. General, ensure electrical controls, wiring, brake regulating equipment is intact and connected correctly. Refer to applicable locomotive service manual. Check service data, tandem assembly, front 1/2 inch box, rear 1/2 inch box, disassembly procedure, number 1, number 2, number 3, number 4, resistance motor tap control, and high pot 3200 VAC 60 Hz for 1 minute. Reference maintenance instruction 4104 locomotive service manual. That was Electric Motor Division, General Motors Corporation, maintenance instruction for the dynamic braking grid resistor MI 1601.